Welcome to our esteemed author team of the Applied Statistics in Business and Economics, 7th edition. David Doan and Lori Seward are going to discuss teaching business statistics using statistical tools and a focus on R and Excel. And I'm going to let you take it away so I don't take one more minute of your time.
Good morning and good afternoon, everyone. I know that we've got folks calling in from different time zones. So welcome to Teaching Business Statistics Using Statistical Tools. And Harper, if you just pay attention in case someone can't hear me or see my slides, I'm assuming everything is available, but
you sound great. You're very clear and perfect noise level or sound level, and slides are great.
Good, thank you. So here's our agenda for this morning. Brief introduction to myself and my co-author David Doan, and we're going to talk a little bit about how we bring tools to our textbook and our resources that go along with our textbook to help you motivate and inform your students. I'll talk briefly in the beginning, and then I'll turn it over to my co-author David, who will discuss how we approach the use of Excel and R in the business statistics class, and also provide, show you some of the resources that come along with our textbooks, some things that sometimes you may not be aware of, and then hopefully have some time at the end for Q&A. My name, as I said, is Lori Seward. I'm a professor of operations management at the Leeds School of Business at the University of Colorado here in Boulder. And I'm also the faculty director of all of our MBA programs. And I've been teaching business statistics across the range from freshman level all the way through our newly launched executive MBA program, which I'm teaching right now. And my co-author David Doan is Professor Emeritus from the Department of Decision and Information Sciences at Oakland University. And he has also taught business statistics all the way from early undergraduate years through MBA programs and professional programs. Our textbook, Applied Statistics in Business and Economics, is now in its 7th edition. Just came out this year. So one of the several challenges that we face as authors of a business statistics textbook arise due to the fact that so many of us, and everyone out there, teach in different kinds of programs at different levels. Sometimes the course is taught at the freshman level, sometimes sophomore level, and all the way through graduate programs, and in different formats, particularly now, with so many schools rolling out online programs as well as hybrid programs, and hybrid runs the gamut in terms of different delivery models. So it's a real challenge thinking about how to provide resources for folks who teach across all those different areas. The other challenge we have is deciding which topics to include. How deep do we go into each topic? And so that's also a challenge because not everyone uses every single statistical tool that we could include in the textbook. We also have seen over the last 5 to 10 years a huge increase in the demand for online support. And so McGraw-Hill has worked well, in my opinion, to provide tools for faculty to deliver their courses using a digital platform. Most of us use digital platforms now for our courses. And then finally, we hear from faculty all the time that they're looking for new, relevant, interesting, realistic examples to help guide and motivate their students. And so taking all of that into account when we put together our resources for our textbook can be challenging, but we're up for it, and that's why we do what we do. We enjoy doing this. So I'm going to share some of the devices that we've included in our textbook. And then after showing you some of these, then David will take over and talk a lot about how we bring software into the resources and how we use software, how we think about that, as well as sharing with you some of the resources that you may not know about that accompany our textbook. With the evolution of the statistics class, the curriculum, we've seen obviously a much greater emphasis on the topic of analytics. You just listened to analytics in business sports. You're going to be hearing more about analytics later on this afternoon. However, the traditional curriculum for a business statistics course still seems to be the bread and butter of most business schools. We know that analytics as a topic area is incredibly broad, but many of those tools still have their foundation in the statistics world. And so what we're trying to do with our textbook is bridge that gap between the basic statistical tools, even providing some more sophisticated tools, and helping students see where analytics is tied to those basic statistical tools, as well as the applications where they'll see them show up. So one of the things that David and I have really focused on in our textbook is providing realistic application examples, exercises, and so forth. And we do that through a new addition to our 7th edition called Analytics in Action. I'll show you a few examples of those. We have many cases in our textbook that do a deeper dive on how statistical tools are applied in business. We include lots of visuals in our textbook because we know that so many of us can learn better by seeing diagrams and illustrations. And then we've taken an approach with our software treatment in the textbook to modularize it and put supplements at the end of each chapter for both Excel and R. And we also show the use of Minitab and a few other software tools. And that's intentional because we know not all faculty use all software. So we put those at the end of chapters specifically based on recommendations from our users. And then obviously our examples and exercises throughout the book. As I just said, David and I try really hard to make sure that those are realistic and relevant and up to date. So we spend a lot of time updating data with the introduction of new additions. So let me begin with an example of our analytics in action. This one appears in our chapter on regression analysis, and we tie regression modeling to machine learning with the application of how companies perform predictive maintenance on their equipment. Another example in our time series chapter with an investment application. And really this is about how simple descriptive statistics can be used in a very chaotic, volatile market. So we talk about the mean and the variance and the coefficient of variation. Here's an example again from our time series chapter. The housing industry has seen lots of ups and downs over the last several decades, and in particular this past decade has been really interesting, and students are always interested in seeing time series. So this is an application on how you might look for trends or bubbles in the housing industry. Here's an example that I actually really like because it is accessible for students. This is something they can understand. Walmart is a business they're all familiar with, and this example explains how Walmart uses big data. They have a data cafe that they make available for all of their employees who need that data to make real-time decisions about the management of their retail establishment. So I like that phrase, data cafe. We include many cases, and here are two examples, one from our chapter on regression and one from our chapter on time series. Similar topics, import, export, trade deficit, but these are topics that are very timely, and we update this data each time we introduce a new addition and bring in anything that's happening in the world at that point. And as you can see on the right with our chapter 14 mini case, we reference the COVID crisis and how that has affected the trade deficit. Another example from our regression chapter on bank assets and market capitalization, doing a comparison here, and it shows what happens after a logarithmic transformation. So these mini cases do a deeper dive on a business application. We also include diagrams and illustrations. This is one that shows up in our chapter 2 to help students see how to determine the measurement level. We give examples of different types of measurement levels, and we have the text to go along with the diagram, but we feel having both of those helps students better understand the concept. Here is a guide that we include at the end of our chapter on discrete probability distributions. And so this simple illustration serves two purposes. One, to show the differences between the discrete probability distributions, but also how they might be similar so that students can clearly see in one diagram what's going on here. It summarizes what was happening in the chapter. Here's another guide to help students understand and choose which formula they should be using to calculate a confidence interval, and when our Z and T formulas may not be appropriate. You'll notice that we've referenced bootstrap estimation over here to the right. We don't cover bootstrap estimation directly in the textbook, but we have resources for those of you who might be interested in sharing that with your students in one of our resources called LearningStats that David will talk about in just a bit. Here's another illustration showing how the sampling distribution on a proportion changes as your sample size increases. And here's a comparison of the foreign trade in the U.S., imports and exports, and using the log transform. So we talk about why that's a useful tool to use with visual displays in our chapter 4. Now I'm going to turn it over to David, who's going to take us through how we use Excel, R, and introduce some of the other resources that we have available for you to use.
Okay, can you hear me okay?
Yes.
Okay, thank you, Lori. Lori's been talking about textbook features that we use to motivate and inform students about analytics. I'd like to talk specifically about where Excel and R fit in, because that topic comes up over and over. I thought a good place to start is with a visual. We, of course, see statistics as kind of at the root of things. And this diagram recognizes that you can't talk about data mining, simulation, or visualizing without talking about either domain knowledge or computer science. So coding is the big word. Everyone wants students to have coding experience, and the students want it because they know it enhances their resume. Does that come from computer science, or do we do it inside the stats course, or domain areas like accounting and finance and marketing are competing for the honor of teaching analytics? And to what extent should this fall within the purview of the stats course? BStats' strength derives from the fact that it does depend on domain knowledge. It fits within the business curriculum. Otherwise, we'd all be teaching in math departments. But BStats has a unique opportunity to tie these things together. Now, you can't really go very far with data mining. You can do some simulation and some visualizing in a BStats course. And the real question then becomes, what about coding? We know students get coding exposure in Python in high school a lot now. And I'd just like to have a visual on the next slide that shows where this all might fit in. This is a survey done for some global companies that shows Python and Java are basically the tools of the hour. R is way down the list. Business schools kind of picked up on R maybe a decade ago, and they've made various decisions about where to put it in the curriculum or whether to put it. In BStats, very frankly, we have a crowded agenda. If somebody says, we'd like you to teach R coding because, gee, it's a twofer, you know, you can, your students can learn statistics and they can learn R at the same time, they can learn to code. And so they get two things on their resume. That's great, but it's not clear what is the priority to put on R or where to teach it. Now, on the next slide, we show our continued interest in Excel. Excel is the core, the bedrock of a lot of business applications, and it's so widely used. It's not going anywhere, and it's used basically everywhere. So Excel seems to us to remain a very core part of the curriculum. On the next slide, we talk a little bit about R. Now, this diagram is also interesting because it shows on the ease of use and the commonality of use, Excel is way up there. R is kind of way down there, but R is much more capable, obviously. And Python, you'll find kind of in the middle. And some of the tools that were mentioned earlier by Brian are shown on this list as well. So here's where we're grappling with it. Our textbook can provide support for some, but not all things, and to some degree, but not in depth. So on the next slide, I show how we kind of weigh it. Excel's strengths, familiarity. You don't have to tell students why, because you can just look at it and see what it can do. A lot of people underestimate Excel. Spreadsheet modeling is still a pretty big thing in many data mining and analytics applications. And Excel does cover most of the common things we do in stats, which after all probably underlie the majority of business decisions. You don't make all the business decisions with the fancy tools. It's perfect for us for Connect and online testing, but it does lack some tools like logistic regression. Now, R is free, but it ain't free because you have to learn it. It is very resume enhancing, but somebody has to help students grapple with learning to code in R. And if you've worked with R a bit, you find that at least basic R has kind of a finicky syntax. Documentation is not always that clear. Now, there are special packages that make some of these things easier, but there's no way around a steep learning curve in R. And of course, if students are in a lab, it's all set up for them, but if they have to set it up on their PC, it takes a little time. So we have to provide a way to help them with this if we choose to include it in the B-Stats course. So on the next slide, I just summarize the way we see it. We are interested in applications. We've always focused on Excel. It's our go-to software in teaching B-Stats. It can be done. It can be used for the most common tasks, and it fits in nicely with Connect. Now, going beyond that, we have created a series of supplements, which are downloadable from the Connect support website. But we also decided in this edition, we needed to provide full support for R. Now, full support doesn't mean that you force the instructor to use it. It's not built into the chapter. We instead put it in the supplements at the end of chapters, and I'll show you some examples. So we know R coding is helpful and does things, but there are other ways to do it. You know, you have Jump and you have other tools, and it's still not clear to many of us. And frankly, instructors are overloaded in the B-Stats course. They've already got plenty to do. So how much time do you spend on coding? And we want to make it as easy as possible for the instructor to choose. So the instructor can say, you know, I don't really have time to do much with this, but I get it. The school is pressuring me to cover it. But thank you, David and Lori. We have some tools at least we can refer students to. And I'd like to show you some of these things. Start out with Excel on the next slide. You know, textbook can have some introductory things like, you know, what's in Excel. And to the next slide, we show screenshots, but you know, there's a limit to what you can do in the textbook, in print, ebook or print book, either one. Now, what about R? Next slide. You can include in R sort of highlights of some of the things that can be done in R, and this is useful just to look at and maybe use as a display in a classroom, because you can say, hey, look, with one line of code, you can fit a regression and save the results. And then with a few simple commands, you can display them. You can show scatter plots and nova tables and all that. Further, in R, you can do residual plots, histograms, normal probability plots, and things like leverage. You can get the hat values. All you have to do is save your results in an object of your choice. So this is kind of a simple thing, but it's pretty powerful just in the written word, but that's in a textbook, okay? Now, if you have the ebook, you can actually click on this stuff and copy it and use it as a basis for writing some code of your own. On the next slide, we show another example. This is just walking through a logistic regression and showing students how simple the commands really are to get significant output in R for a logistic regression. This is kind of a simplified example of a bivariate or two variable simple regression. Next slide shows an example of something that can also be done in Excel. If you're just going to calculate a mean and do a t-test, you can do that in Excel. The code in R is not really too much to your advantage in this case, and we wanted to make that clear. So at every chapter, at the end of every chapter, we have examples like this, showing how R can be used to do the types of things that are in that chapter. Now, in the next slide, I'll show you something else. We have included two appendices in our book. One is kind of unique. It's a little hard to see, but Appendix J compares side by side the same function to accomplish something in Excel and in R. And you'll notice a lot of similarity. We think it's useful, kind of in the sense of comparative grammar. It's kind of like why Latin helps you understand French. You see them side by side and you say, gee, you know, those commands in Excel, the functions in Excel are a lot like the ones in R. There's, of course, an underlying reason for that. We also include, by the way, this Appendix J goes on for several pages and includes hypothesis testing and distributions and all kinds of stuff. This screen I chose was descriptive statistics. Now, Appendix K walks a student through installing R, and several pages long, helps them get set up. So an instructor can say, I refer you to Appendix K, and by the way, you can copy this stuff if you have the ebook. It's pretty straightforward. Now, on the next slide, I show how we can do more if we go to Connect. Now, Connect, at the circled thing on the bottom, we're talking about instructor resources. A lot of instructors may not quite know what's there. So I'd like to point out some things that are there in the Connect library of instructor resources. On the next slide, you can see all the usual stuff. We have test banks and data sets for each chapter, which, by the way, are compatible. We have PowerPoint presentations and digital images for every diagram in the book, the usual sort of stuff. So instructors can use it to teach analytics in their classes by just bringing those things down. And of course, we have SmartBook, and some instructors may be using Megastat. There are tutorials, all kinds of stuff. I want to focus on two items, which we believe may be overlooked by some instructors. So if we have time, I'll talk about big data sets, but I want to focus mainly on LearningStats. So if we look at the next slide, LearningStats is not part of the textbook. It's purely electronic, it's downloadable, and it has a bunch of demos that students can use to explore topics in their own way and in their own time. It follows the textbook. The units are labeled exactly matching our book, but it's independent. It's different. It's light. It's easy. They're designed to be self-explanatory, and it will help them with things like math review, technical report writing, and making presentations, things that you really can't do in a book. We have tutorials on R. We have deeper explanations sometimes for topics like a partial F-test, something we don't choose to get into very much, or bootstrap method. We have quite a bit on bootstrap, including some demos. And the one thing I'd personally like to kind of focus on a bit is PowerPoints that we've prepared to use by instructors in the classroom or by the students on their own. So on the next slide, show you kind of what LearningStats looks like. I don't know if instructors are aware that we have downloadable tables for all the distributions. We have an appendix on business report writing. We think that's hugely important. We have stuff on oral presentations. These are PowerPoints, but they're easily, they're set up for students to walk through or for an instructor to walk through if they feel like it. We also have self-tests of various kinds. Now, when we get to the nitty-gritty, chapter 1, we have tutorials for Excel, PowerPoint. Okay, we have it for the Mac. We have tips on using Excel. I'm just going down the list. In Unit 1, we have a PowerPoint on using R and RStudio, how to install it, and then we compare the functions in the 5th item. But we also have a lot of stuff that, frankly, instructors don't have time to get into. What are significant digits? How does that work? We have a math review. We have guides to software with clickables. Students can jump around. They can go to different sources of data, different instructors that have put things up, different government websites, and so on and so forth. Data collection, we have in every chapter a module on using R. So using R for sampling. We also have tips on making surveys. These are things that are not covered very deeply in most classes. On the next slide, I'll just show you a few more. I'm not going to go into detail, but you'll notice that every unit has an R and an Excel PowerPoint. Now, these are not textbook. This is not repeating the textbook. This is highlighting and helping students in a very informal way walk through this stuff, or helping an instructor if they want to kind of lighten it up a little bit, walking them through these. I'll show you some examples. On the last slide here, I just want to point out that there are some things that you may not even know about. There's a chapter 18, which is not even in the book, simulation. How do you teach that? You don't teach it in a textbook, I don't think. But we've created some examples that you can even do in Excel. These are simple simulations, just Monte Carlo. We did have some that were used at risk, but very few people seem to have access to it. So most of these are just Monte Carlo Excel simulations. But we also have PowerPoints we actually have a chapter on simulation that shows you all the main things we think you should know. So I just wanted to include that. And on the next slide, I'll show you some more about, this is just our PowerPoint on learning to use Excel. Doesn't look like a textbook. Notice it's got clickables. You want to know about, I want to use pivot tables. So your student goes to slide 1, they click there, and it'll take you to a slide that helps you understand pivot tables. Oh, gee, I think I want to use Minitab. Well, you can click on it and it will take you there. So this is an Excel tutorial primarily, but it has a few add-ons. Next slide just shows that we don't skip anything. We show them, even instructors don't want to talk about the file ribbon and stuff like that. And students probably know that, but maybe they don't. So they can refer them to this tutorial. Next slide shows an example of a demo. This is a very simple simulation of random sampling of sample sizes, 5, 10, and 20. It shows you visually a confidence interval for each of the means, and it shows whether or not it includes the true mean. I don't know if you can see the diagram there, but you can't do that in a textbook, but you can do it in an Excel demonstration. You press F9, you get new samples, and we have some in these demos, we have a little yellow box asking some questions. A student can ask themselves those questions, or an instructor can assign a student. I've had some success asking my students to try some of these and then report back to the class. They find that kind of fun. Next slide shows R. Now this is just a PowerPoint, but it's not just any PowerPoint. We try to make it really light. We're not hammering away at R. This is one sample test, a very common thing to do. But have you ever seen a slide that compares side by side how you get a critical value and a p-value in R? It's a lot of information in one slide. And if you have, because it's electronic, you can copy those. And if you're writing code, student can copy those and use them as a syntax for their work. Now, in the next slide, I'll show you a little more detail. We have detailed examples. Notice that they're light, they're very readable, they're color-coded, they have tips down at the bottom, and a student can literally copy that code and paste it into R and use that as a model. How do we learn coding? I think a lot of us learn it by example, don't we? You just get one that works and then you modify it and tweak it until you make it do what you want. So on the next slide, see another example, illustrating regression. How do you get some of the things you can do in R that you can't really show in a textbook? There's just no way to fit all this in a book. Plus, it's more alive if you see it electronically. And I think students prefer that. And on the next slide, there are things in R, obviously, you cannot do in Excel. This shows how you can get leverage scores out of R, which you can't do in Excel. And we even include rules of thumb for leverage that we talk about. And we even include some interpretations in the bottom. You notice a little clippy thing. I don't know if people like that or not, but it lightens it up. And we think a few pictures kind of lift this out of the realm of textbook learning into the realm of kind of more fun, self-paced learning. And we'd like to conclude our R tutorials with some advice. You know, what can R do and why do we want to use it, and what are the pros and cons, and maybe what are the alternatives? Would you rather use Jump or something for the same thing to do this logistic regression? And then on the next slide here, just kind of wrapping it up here. I don't know if we have time. Are we okay on, do we have 5 minutes or so? Okay. A lot of instructors seem unaware that our downloads include what we call big data sets. Now, I want to qualify that. Big, to many of you, means gigantic, millions of lines of information. These are not that big. They're big enough to be somewhat realistic and interesting and challenging, but they're not the kind of thing where you really have to do data wrangling. But they automatically suggest themselves to certain kinds of statistical tests. To make it really straightforward, we have even added color-coded little icons on each data set so that you know which ones do what. So some of them are good for just describing things or fitting trends, doing correlations, chi-square tests, and t-tests and ANOVA, that type of thing. Now, the first data set I'll talk about, by the way, these are just downloaded from the Connect website. So in the first example, this one, we have a document that lists all of the big data sets, all 25 of them, and they show a little quick summary, just like this. This is copied right out of that. Here's an example of only 41 banks, but oh my gosh, you have 14 variables. You know, that's a little overdetermined. What are we going to do with that? But you can do quite a bit. You can do histograms. You can do data transformations to show, for example, assets is going to look really funny on a histogram, right? Because it's highly skewed. JP Morgan pretty much has so much. And down at the other end of the list, we're showing the first and the last three observations. Commerce Bank is almost non-existent. So you can talk about data transformations. You can talk about correlations between different variables, including the revenue of the banks and their deposit level, ratios, assets to employee ratios, stuff like that. Just describing data. But this is very suggestive. Any instructor, or even a student, will just look at this and say, oh, I know, I can do some stuff with that. Another data set. Next slide. Sports. Brian was talking about sports earlier. We know students like sports. There's an ambivalence about sports. Some instructors say, hey, it's a B-stats course, so we don't want to just do dice rolls and sports data. But the reality is students like it. They like sports, and they're interested in it. This data set, I don't know that I've really heard instructors talk much about it, but we have 1,472 basketball scores from first round NCAA March Madness, showing basically just the points scored by the winner and the loser. But we also have the information that tells you which team was higher ranked, so they can actually count the percentage of times there was an upset. They can break it down by gender. You have men, you can do t-tests. Is the win margin different between men and women? Is there a trend over time? Is the margin diminishing? We have, what did I say here, 23 years worth of data right up through the latest year, and we update this annually. So you can ask, is the win margin getting smaller over time? Are they getting tighter, or just what's happening? And what constitutes a blowout? Well, you can define that statistically and play with this. So there's a lot of information, gender, time, all kinds of stuff. And the last one I want to just mention here for no particular reason is vehicle mileage is talked about quite a bit. It's almost a non-topic anymore because we're all going electric. But what is the effect of a vehicle's style, its length, width, height, weight on the mileage? These are all non-hybrid vehicles, and this is current data right off the manufacturer's website. So it's very fresh. You don't use this to make decisions about what car to buy, we hope, but it's very interesting. And with 16 variables, you can do a lot. You can do histograms, you can do classifications, or correlations, all kinds of stuff. And of course, what you find is, if you're doing regressions, it shows the problem of having multicollinearity, because so many of these variables are intercorrelated. So you can raise a lot of interesting questions. Well, anyway, I hope I've given you a little hint as to how analytics kind of ties in with some of the stuff you can do electronically that you can't do in a book. And I don't know how much of this instructors take advantage of, but we wanted to give them a choice. So I'm going to hand it back to Lori.
Thank you, David. So happy to have the two of us answer any questions that you might have.
Thanks, David. I did get a private question asking about whether all of the data sets that you were showing, how those were available to, were they available? How did you acquire the data sets, and where they're, if they can use them and where?
Yeah, we've tried to use, for the big data sets, tried to use publicly available stuff. Now, some of it comes from Wikipedia. I guess that's debatable. But is that your question? They're documented to the extent.
Yeah, and I think it's helpful that you're showing this resource in Connect and where to find the information in Connect. I think that's what the question was.
Okay. Yeah, but I think there's
Can't assume that everyone knows
I think
Connect.
there's an intellectual property question there too. We try to use stuff. The challenge with analytics is, companies protect their data, so you have to be careful. So we try to use public sources, Federal Reserve banks, anything that's not proprietary.
But Harper and Eric, so if a professor is not using Connect, they do have access to these instructor resources by going to the textbook link. I think you provide that, correct? Either they can get to it from the library in their Connect course.
Correct.
Or,
yeah, so you're no longer providing that, extra link. They can get access to Connect, and then all of the resources are available to an instructor. Ideally, if they have the student, also purchase Connect, then the student will be able to, will have access, but the instructor does have access even if they're not using Connect. Yeah. So this is great. It shows all of the instructor resources and where to find the big data sets and the learning stats. And just to reiterate, the LearningStat is an exclusive to your product. So I just wanted to reiterate that.
Yeah, it accompanies our textbook.
And we realize there's more in LearningStats than anyone can use, but in a way that's not a bad thing.
Where did that originate from?
It's been a kind of like sedimentary rock. It accumulates over time. We've kind of improved and tweaked, and last edition we kind of gave it a little bit of a refresh, so everything is up to date as it can be. And I don't think Eric asked the questions will help pick his NCAA bracket. I wish.
All right.
Sounds like you need some help.
Yeah.
All right. Well, that was a great demonstration. I do not see any other questions. Do you have any others, Eric? All right. Well, I thank you. Thank you, Lori and David.